Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amdan. Now we want to present for our project that is computer performance with different memory using direct method cache for the subject computer architecture and organization. For the outline, cache memory is a type of memory that operates at the very high speed. It's used to boost performance and synchronize with high-speed CPU. Cache memory is more expensive than main memory and disk memory, but it is less expensive than CPU register. The goal of the research is to determine how well computer perform when employing different type of memory and a direct map cache. Based on their performance, the study will show that the most efficient mapping is a associative mapping. The simulation utilized in this research has limitation of just being able to test the cache hit or miss rate only. Next is the introduction. A cache is a small, quick memory that store copies of a part of the content of main memory. The cache gives faster access to the CPU. Since it is quick, yet because it is small, not all requests can be satisfied by the cache, requiring the system to wait for slower main memory. In this project, this is a computer that the topic is computer performance with different memory using direct map cache. We was set up for the size of cache is the same, that is 16, while the size of memory that is different, 32, 64, 128, 256. By using direct method cache, we can know statistics of hit rate, miss rate, and memory block. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zuhair from Ferhat and my card metric number is CE190248. Okay, so now I want to talk about methodology. Okay, first one is the flowchart. Okay, first we start with the start and then understanding the question given and the equation, objective of study, methodology of study, and then result and analysis, which is we do the simulation, and followed by the conclusion and the end. Okay, next for the simulation, we use the direct map cache software. The direct map cache software is simple and inexpensive to implement, but if a program access to block that map to the same line repeatedly, the cache begin to trash back and forth. Reloading the line over and over again leads to high miss rate. The requested address is broken down into tag, index, and offset. Next, the cache table is corresponding index will be examined. If valid bit of index is equal to 0, cache miss is obtained. Else, tag bit of requested address will be compared with tag bit in cache table. If tag is matched, cache hit is obtained, else cache misses obtained. When cache hit is obtained, the data from cache table will be returned. The data will be received from main memory.
Hello, my name is Muazzan bin Mukhtar. For my part, I will present about the coding explanation. On this project, we use the Paracache simulator. For the first step, we need to declare the cache size, memory size, and offset bit. The cache size, we use the constant value, which is 16. And for the memory size, we use a different size. Start from 32, 64, 128, and 256. But for this example, we use the 256 for the memory size. And for the offset bit, we use 2. And then we submit the value. After we submit the value, you can see the information below. This is the offset. It's 2 bit. We have declared for 2 bits, and this is index bit. This all automatically calculates by using this simulator. And the instruction length is 8 bits, and text is 4 bit, and the blocks is 6 bit. And for this instruction, we can insert 10 maximum value in hexa, and this one is the initial value instruction. And then this one is the instruction breakdown. It's the value for we have to the information calculate the tag bit. The tag is 4 bit and the index is 2 bit, and for offset is 2 bits, and this means this one is 000, 00, and 00. And for the memory blocks, B is the blocks and W is word. You can see the words is start from 0 to 3. It means we have 4 words, and the blocks start from 0 until S3F. It means 63, but means 64 blocks. And next is the cache tables for the initials. Okay, for the first instruction, it's just submit, and then the instruction has been converted from hexa to binary. Let's look at the text index and offset. This one is 0, 0, 0, 0, 0, 0, and 1, 1. We convert to hexa to binary, value of 3, and then just next. And index request will be set in the cache as highlighted in yellow. The index is high in the 0 because the index value is 0, 0. And for the 1 is the 0, 1, 2 is 1, 0, and 3 is 1, 1. Then just next. The valid bit will be contained and analyzed, and the following analysis diagrams. The valid bit is 0. This is because there is no value has been saved in the memory and in the cache, so the cache will be missed for this part. Next, and then the cache table is update the coordinate to the block 0 and word 0 to D3. Instruction is 1. Just submit, and the value in hexa1 convert to the binary is 0, 1. And the index value at the 0, and obtain and analyze. The valid for this one is valid bit is 1. this is we should look at into the text, the request text and the cache text is the same value, so the cache will be hits. And then next, and the cache table is updated to accordingly to the blocks 0 at the offset 0 to 3. And the next instruction is 28, the submit value. Index request in the cache. Index 2 is 0. For this one, the valid bit is 0, but this is different on the cache, on the request text and the cache text, and the compare will be the compare value and will be the not same, and this means the cache will be missed. Then the cache will replace on the all index since the T bit is 0. There is no additional operation required. And then the cache table will be updated at the block A and offset 0 to 3 and transfer to the cache. Okay, after all the instruction cycle has been complete, we can see the final of the cache table. This one, we have the index and the value, and the text and the data hex for the blocks. And at the below, we can see the statistic for the hit rate and miss rate. And for the hit rate, we get 36%, and the miss rate we get 64%. We can conclude the miss rate is higher than the hit rates. And at the below, for the below statistic, we can see the list of previous instruction where is the instruction has been missed and hits. Okay, that's all for me.
So, Assalamualaikum to Dr. Nik Shahidah. My name is Muhammad Hidayat bin Muhammad Noor. My metric number is CE180064, and today I would like to present about our project, as I am handle the conclusion, recommendation, and also the personal question, Q&A question. Okay, let's start with our conclusion. The conclusion is we are able to understanding the flow and the function of Catch Simulator, which is an educational web-based simulator for catch and virtual memory. And also we are able to identify which performance between the size of catch and its memory size is better based on its hit and miss rate. So for the next slide is recommendations. For our recommendation is add multiple choice of instruction that needed to be loaded into the memory to know its performance based of different instructions, using different method of the Catch Simulator, which is we are using a direct map. So there are other methods such as fully associative catch, two-way SA, four-way SA, catch type analysis, and virtual memory, so that more knowledge we can be obtained about the memory. And lastly, the usage of different write policies such as write through or write around. So we are using a write back for our project.
For question 1, what are the unique features of your child or project? The unique features of our project is we learn to test the cache performance using the Catch Simulator in direct mapping cache. From this simulator, we know how the cache and memory function in computer system.
For the Q&A question, so my question is, what does current trend of computer architecture with your project? So the answer is with the increasing of computer demand, we need the efficiency and the effectiveness of cache and virtual memory.
So it's become an important area to be looked into. By utilizing the correct catching method, which is this method, and architecture will achieve maximum performance with minimum resource. So to choose the appropriate configurations, the fundamental of cache and virtual memory must be understood by every engineer. So that's all for me. Thank you.
For the question number 3, explain on how your project can support the sustainable development. This study can assist to promote sustainable development by making education more accessible. According to the finding of the study, computer will enormous memory aid to facilitate learning, which is one of the sustainable development goals. This can be noticed when it can assist students completing tasks and finding information utilizing internet access more quickly.
The Q&A. Explain the current trend of computer architecture for sustainable development. Okay, so for me, over the same period of time, the rise in the use of computer have increased manifold. The combined effect of energy needed to run this device and the electricity required to maintain the cooling infrastructure for this device have an impact on the environment. This is an area of serious concern and is growing for people for research in the field of green computing, which is about using computer in an eco-friendly way. Okay, that's all from me. Thank you.